Okay, we're going to be examining the forces between current carrying conductors. This is chapter 30. As with the other videos that I have uh, worked on, whenever I ask a question, ask you to verify something, ask for a calculation, pause the video before I actually do it. Try to work it out yourself. This way you get the maximum benefit out of the video. From section 30.1, we have that the magnetic field of a straight long current carrying wire is given by B equals mu naught I over 2 pi r. Now this was determined by the Biot-Savart law, and you should have studied that in the examples in that section. The magnitude is mu naught I over 2 pi r, and you can use the right-hand rule to determine the direction. Now I show on the left the axes, the k hat direction, the j hat direction, and the I hat direction, which is out of the page. We start with one current carrying conductor, I, in the direction of positive k. We symbolize R, the vector perpendicular from, or just the vector, it doesn't have to be perpendicular, but the vector from P to I. Okay, and where the magnitude of R is just simply the distance. Also, based on the right-hand rule, where the thumb is aligned along the direction of current and your fingers curl in the direction of B. So B here would be going into the page. Now use the right-hand rule and verify that the direction of the magnetic field is correct. Pause the video. What is the magnitude of B at that particular point, P? Of course, that is simply mu naught I over 2 pi r. What is the direction of B? Can you write that in terms of the unit vector? Pause the video. And of course, that's going to be in the minus I direction. Now let's place a second current carrying wire. We're going to run it parallel to the surface, parallel to the wire on the left, passing through point P and the current in the same direction. So I draw the current carrying conductor, and you can imagine that these are straight lines, even they don't appear to be so. Now what is the force? We now know what the B field is on that current carrying wire. So the question is, what is the force? Pause the video and work it out. Well, the force of a current carrying wire in a magnetic field is IL cross B. It's the cross product of the length times the magnetic field. Carrying out that cross product, I get ILB to the minus J direction. Now, verify that everything I have there is correct. Pause the video and make sure it's correct. Verify it simply using the right-hand rule. Now, what is B from the wire on the left? And that's simply mu naught I over 2 pi r. So now how can we combine this in the equation for the force? Because we want B in terms of the current. So what is the force on the wire on the right, the current carrying wire on the right, in terms of the currents of both wires? Well, I can write that the force B is equal to IL times B, which is mu naught I over 2 pi r, and that's equal to mu naught I squared L over 2 pi r. Of course, if the currents were different, I would have to label one I1 and one I2, or one IA and IB. I would have to distinguish between the currents. In this case, I have picked them so that the currents are the same. And we can write, instead of writing the force, we could write force per unit length. And just simply divide by the length, and we have that's equal to mu naught I squared over 2 pi r. And that's the end of this.